about sequence. So we study in detail this guy. Okay, basically this is easy because it's a functions. It's a function that includes natural numbers. So we start in 1, no in 0. 1, 2, 3, 4, 5. So it's a function. It's a function whose domain is a natural number. When you're talking about a natural number, it's 1, 2, 3, to infinity, right? And you associate with the formula real number. And the formula give me the explicit. And normally the terminology gets used in that part is A sub m. A sub m, and we declare the formula, and that's it. Suppose 2/3 raised to the n power. Entonces you really need to find the first term of this. A sub 1, A sub 2, A sub 3, A sub 4, and A sub 5. Entonces, when you raise to the 1 power, it's 2/3. When you raise to the second power, it's obvious get 4/9. No? Over 9? Yeah, over 9. Because it's 3 to the second power. To the third power is 8/27. Because it's 2 to the third power divided by 3 to the third power. And so on. This is just plugging in, and that's it. Easy. This is 16/81. And to the fifth power is 32 over 234, I guess so. So it's 81 times 3, no? 81 times 3 is 243, yeah. 243. Okay, in this case it's easy because we have a formula. We have the explicit formula. But not always we have the explicit. Okay, this A sub m I call explicit formula of the sequence, no? Sometimes it's or too hard or impossible. Find the explicit. I bring one example to illustrate this. This is one sequence, famous sequence in mathematics is called Fibonacci. Fibonacci is the last name of the Italian mathematicians here. Fibonacci. Fibonacci sequence. This is a good example. It's too hard. Find the explicit formula. And actually, we don't have the explicit formula. So we have another formula that is called recursive formula. Recursive formula. Let me explain the idea behind recursive formula. To explain the Fibonacci sequence, you suppose, guys, that we have the, the animals. The example that is in the book is always rabbit, but actually it's not rabbit. But okay, it's an animal, and we have one adult, big adult animal, and give me two animals, another big, okay, by the way, it's the same, and one is a son, it's a child, it's a little. Entonces, in the next step, the big is split exactly like that, big and little. But this little no, this little convert to big. Okay. And so, what is the next step? Well, the big is split and big and little. The little is converted to big, and the big is converted to big and little. Do you understand the idea for the sequence? So we have one rabbit, I don't know, rabbit, adult rabbit, and they have a child, little rabbit, and this stays the same, no? You count. Also, as you see, at the beginning we have one, here we have two, after we have 3, we have 1, 2, 3, 4, and 5. What do you expect to get in the next time? Do you see the sequence? Do you see the combination or no? Do you see the formula? It's a little bit hard, no? Or no? Do you see or no? Answer me. So in the next step, how many rabbits we have? The big again is a big and little, and the little converted to big, and this big is big and little, and this is again big and little, and the little become too big. In total, 1, 2, 3, 4, 5, 6, 7, 8. Do you see the idea? So what is the formula? No formula. Well, they are a formula actually, but it's very, very complicated. However, you can use a recursive formula. What is the idea behind recursive formula? Well, the idea is that you somehow relate the quantity in the current time and the previous, okay? And you see that these 3 come from addition 1 plus 2. Do you see? 3. And this 3 is addition 2 plus 3, so 1. Okay, wait, in the sequence we have 1 plus 2 is 3. Well, 1 plus 1 is 2. You bring down this is 3, and bring down 3 plus 2 is 5. And finally 5 plus 3 is 8, no? Okay, this is a formula. This is a formula. The formula is, in order to find, for example, this guy, I want to call A sub m, we have no formula. But I know que is the 2 previous, que is A minus 1 and A minus 2. This indicates the index addition. So the formula is A sub m is equal to A sub m minus 1 plus A sub m minus 2. And this is the recursive formula. Okay, it's possible or no? Find the formula. Yeah, it's possible, but it's too hard. It's beyond the expectation of this class. So now, sometimes the sequence is convenient using the recursive formula, and sometimes no. Sometimes you have the explicit formula. Do you understand the idea behind recursive formula? It's just an example. Clear or confused? Guy, are you there?
It's clear.
It's clear. Okay. So now let's move on to the summation notation. Summation notation. Very useful in calculus. Okay. When you have a sum, suppose you have A1 plus A2 plus A3 plus that. And this continue not forever, continue plus A20. So the long is 20 element. You can condense it using this symbol, sigma. This is the Greek letter. The Greek letter is called sigma. Sigma, and you try to put the explicit formula here. And you declare one index variable, suppose m. The most common index variable is n, or k, or I, or j. It's the most common. Doesn't matter what you use. And you declare the first one is n equal 1, is this one. And 20, n equal 20. I don't know why sometimes it's written in that way, and sometimes reading this, n equal 1, to 20, not necessarily put n, because I suppose it's a sub n. Oh, some people declare it like that, 1 to 20, a sub n. This is indicate summation, addition, subtraction, addition, not subtraction, addition. Let's see an example of the summation notation. Suppose k is given in calculus, k equal 1 to 5 of 1 over k. It's a formula. And you expanding the summation notation in several. Well, how many guys we have? Well, we have 5, no? 1, 2, 3, 4, 5. Okay, so 1, 2, 5 include both endpoints, no? The first one you plug in is 1 over 1. Okay, it's just 1. 1 over 2. 1 over 3. 1 over 4. And 1 over 5. Done. Here's the answer. If you want, of course, 1 over 1 is 1, no? And I decided to put 1 over 1. It's just 1. And this is the idea. Okay, basically the thing we're doing is expanding summation notation. Let's do in power. Let's do it now, condensing, right? As summation. Suppose you have, right? Another action, right? A sum in summation notation. Suppose we have 1 square plus 2 square plus 3 square plus bam 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 3 dot, no 4. That indicates also que continue, not forever, sino continue following the same sequence. So next guy 4, 5, and so on to 9 square. So you write summation notation, and you declare que the variable suppose k. I like so much k. I don't know why. From k equal 1 to 9. All the expression is k squared. You put exactly the same variable que you declare in the summation limit, upper limit and lower limit. And the formula inside the summation, well, depends on the same variable that you declare. Do you understand the idea of the summation? Okay, so we are using now in the problems. Very important in calculus. Very, very important. Okay, let's study in detail now some property, important properties of summation. Okay. The first property say, number 1, property 1. Suppose you have summation. Summation from k equal 1 to m of the one thing is a constant c. C is a constant multiplication by a sub k. It's like you multiply by one specific number, c is a constant, any term inside the summation. Entonces es obvio que we can factor out because it's the same factor. It's multiplication, the summation, a sub k. Okay, so we can apply in the directions, factor out, factorization, or multiplication in different directions. Property number 2, super important. When you have summation from k equal 1 to m, and we have inside the summation 2 sequences, plus or minus, doesn't matter. You can separate like that. This is obvious, right? Sometimes we have a very, very complicated expression. And so you don't know, wow, it's complicated. No, it's not complicated. You separate in 2 easier. Okay, into easier expression. Okay. And the property number 3, que es important but not too much, is when you have, for example, one summation que start in 1 to m is okay, and you separate, you break it down into summation. K equal 1 to m is okay plus another summation from k equal m plus 1 to m is okay. One example, suppose that we need to compute the summation from k equal 1 to the 500 of the one expression that is 1 over k. We can separate like that, k equal 1 to the maybe 200 or 300 or 400, 1 over k plus another summation que start in 201 to 500. Is it clear, right? Is it clear? Well, Professor, but what is the reason? I need to separate. Well, the reason is that sometimes in the problem, you see that we have a summation that start in 201 to 500. 1 over k. Okay, by the way, is this. However, you have no the formula to compute that. However, you know the formula very well when the k is 1. So basically, I compute this summation and subtracting, so I minus this summation. And you compare it from 201 to 500. When the limit is not 1, so you apply that property, but like in opposite direction. I promise you see example. Don't worry for this. I only say the property. Maybe you get the roughly idea, and the rest is application. But we have 4 more important properties. Okay, this is the most important in calculus. Okay, property 4. Property 4 is, suppose you have summation from k equal 1 to m of the one specific number, c. Well, see, this number is constant and do not depending of k. It's obvious that this is multiplication. This is n times c. See, this idea is not clear for you. Suppose one example. Suppose k equal 1 to 20 of the 40. This is equivalent to say 40 plus 40 plus 40 because this doesn't depending of k. And this is 20 times 40, no? In total. 20 times 40, therefore, the answer is 20 times 40 is 800. Make sense? Property 4. In conclusion, when you have a constant, okay, the super efficiency way to do is multiplication this times this. But this is on the supposition that we start in 1. See, we don't start in 1. Let's see what happens. Maybe you're using that property. But I don't want to anticipate this. Everyone follow me so far, guys? Answer me.
Yes.
Okay.
Yes.
Suppose another property, number 5, important, the most important property for me. K equal 1 to m of k. It's like a 1 plus 2 plus 3 plus plus m. It's addition the first m natural number. So what's the formula for doing that? This is one famous problem. Okay, Euler was a mathematician here, the best mathematician in the history. When he has in the elementary school, the teacher was the time put for a student this problem, no? 1 plus 2 plus 3 plus 4 plus bam 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 to 100. And the student doing it that way. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. And the student consuming time, however, here are doing in 5 seconds. Using this idea, look. He expand in both directions. How in both directions? Well, suppose okay, we have 100, 99, 98, 97, no? In both directions. And Euler doing this operation first. 1 plus 100 is 101. And he saw, okay, 2 plus 99 is also the same number. And 3 plus 98 is the same number. Wow. So how many couple of the number, the addition give me 150? 50 because 100 divided by 2, no? We have 50 couple. Okay, give me 101. The answer is 5050. This is the idea behind that formula. The formula is, look, m plus 1 divided by 2. In our specific example of the Euler, a summation k equal 1 to 100 of k is 100 times 101, okay, is 100 plus 1 divided by 2. And 100 divided by 2 is 50. And 50 multiplication by 101 give me 5050. You get the idea? You don't need to prove this. Only you using the formula, and that's it. I illustrate where I come from this column. There are another formula more complicated. It's a little bit hard to prove this. Okay, property number 6. Summation from k equal 1 to m of the k square. Wow. This is equivalent to say 1 squared plus 2 squared plus 3 squared plus bam 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 plus m squared. And the formula is more complicated. It's m plus 1 to m plus 1 divided by 6. In your moment, I want to explain one fantastic way to prove this using another tool that you don't know. This is property number 6 and the property number 7. Any property we use in calculus, like property number 7 is summation from k equal 1 to m of the k cubic. It's 1 square plus cubic, 2 cubic plus 3 cubic plus n cubic. And the formula is similar to the first power. It's unbelievable, but it's true. It's n plus 1 divided by 2, everything is square. This is the beauty of the mathematics. And the problem we are solving is the combination, the 7 property, no? Multiplication by constant. Outside you can split in 2 pieces. You You split when the limit is not 1, and this is the formula when the limit is 1. Property 4, 5, 6, and 7. Let's do an example. Let's do an example. Let's do an example. Any question? No? What do you think about this topic? Is easy or complicated? Easy or complicated?
I think it's okay.
My colleague in college say the easy topic in mathematics is a sequence. Because of plugging in, and that's it. It's a formula. Suppose summation, compute that. Summation from k equal 1 to 5 of 3k. Okay? Well, we can use so we can do in the not incorrect, the long way is plugging in 3 plus 6 and so on. However, using the property, you see that this 3 is a constant and you put outside the summation. Yeah, I know the formula for this. The formula is 3 times, and this is 5 multiplication by 6 divided by 2. And the formula, remember, was n plus 1 divided by 2. N is 5 in our example, 5 plus 1 is 6 divided by 2. This is 30 divided by 2, 15, times 3, 45. We can do in the long way, yeah, of course, but no, I don't like the long way. I like the easy way. Look, what is the long way? Suppose k equal 1. Entonces, 3 times 1 is 3. Suppose k equal 2 is 6. 3 times 2, no? 3 times 3 is 9. That was for k equal 1. K equal 2, k equal 3. K equal 4 is 12. And k equal 5 is 15, no? Okay, now this is 9, and 9 is 18, and this is 27, no? And 45. Now you see, well, Professor, I like that way. Okay, suppose here I put 500. You can do it in that way? No. Okay? Okay, example 2. Suppose summation k equal 1 to 20. Oh, it's a little bit long. Not too much, but it's long. Of the one expression, the 5k plus 3. Okay. You can do that in this, but no, in my opinion, you separate in 2. Okay? Why not? This constant, I know very well, can you put outside if you want, like a common factor. Super. Now, I apply the formula, and the formula say get 5, and this is 20. 20 times 21 divided by 2. Multiply by 5. And this is a constant, and the constant, when this is a constant, you multiply 60, no? We're going from 63 times 20. So you compute this is 1050 plus 60. is 1110. Okay, you apply different property for the summation. Remember, a constant you put outside the summation and you apply the formula when it's k or when it's k squared or and so. It's clear or no? It's easy this topic or no? Okay, I want to complicate this. Now start in 0. Entonces, any formula que we using in the property starting 1, never starting 0. Okay, entonces I can do that. Yeah, of course you can. But you expand. So you are in 0 first. So this is equivalent to say, look, equal, and suppose k equals 0, entonces 0 squared minus 4, no? So k equals 0. And for k, after it's greater than 0, is summation, k equal 1 to 14 of k squared, if you want to separate, plus no minus, because 4 is negative, minus summation, k equal 1 to 14 of 4. This is negative. Make sense? And this is obvious que es negative 4. This guy is negative 4. 0 squared minus 4. And this no. This is using the formula. What formula? The formula. Let me copy the formula one more time. Summation k equal 1 to m of the k squared. As we are formula is m plus 1 to n plus 1 divided by 6. Guys, I promise que in calculus you need to use in that formula. No every day, pero you need to use. Entonces, m es 14. O sea, 14 multiplication by 15. Where come from 15? Well, 15 is m plus 1. This is 14 in our example. This is 15 in our example. And this is 29, no? Because it's 2 times 14, que es 28 plus 1, 29. Divided by 6. Minus, oh, this is a constant. This is a constant. So si it's a constant, you multiply this and this, it's 64. The rest is calculated. You put in the calculator, this is negative 4 plus 1015 minus 64. The answer is 955. Don't hesitate to use the calculator. The most important is not that part. The most important is apply the formula and separate the summation and the corresponding part according to the property of the summation. Okay? Everyone follow me so far? It's complicated. No? Okay. Let's see example 4. Okay. In example 4, we have summation from k equal 10 to 60, sorry, of the 2k. Compute that. So you can evaluate, 10, 11, 12, no, using the formulas. Well, first of all, I realize que the limit, the lower limit is no 1. So now I need to split this summation into summation, no? 1 starting 1, exactly our formula is split to 60. Minus another que start in 1 to 9. Why to 9? Because 9 is the previous 10. So this is completing the sequence. So this is 1, 2, plus, no? 3, Actually, no, 1, 2, 3, it's the index. Now, to 9. And the next is 10, no? 11, boom, 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 to 60. I want that summation. So I need to find this summation from 1 to 60 and subtracting this summation gets from 1 to 9. Makes sense, right? It's easy to understand. No, I explain sometimes the students don't understand this. Clear? Now the rest is pretty easy. These two is factor out. Why not? You can, for example, these two you put outside. It's a common factor. And you have summation from k equal 1 to 60 of k alone minus another summation from k equal 1 to 9. Okay. Because the only thing I did was these two and these two put outside. This is a property of the summation. Summation is linear operator. Linear operator means that any constant that you multiply, you can multiply inside or outside, either way. And it's linear operator because you can separate. So you have different factors. In the formula, you can separate like addition or subtraction, depending the sign. Okay, now easy. This is 2 times. And you apply one more time the formula. What formula? That formula. Summation from k equal 1 to m of the k is m times n plus 1 divided by 2. And our specific example is 60 times 61 divided by 2. Minus 9 times 10 divided by 2. Okay, these two is cancelled. It's a coincidence. And you apply the calculator. 60 is let me use the calculator, my own calculator. Is 60 times 61 is 3,660 minus 90. Now subtraction. 3,570. Nice, is the answer. Okay, be careful because my formulas always starting from 1 to m. So you are truncate summation, so you need to split. And be careful with the split. From 1 to 60 to the 9 to the 1 to 9. Okay, the other part. Do you understand this or not? Answer me, please. Do you see before this in the high school or not? Summation notation.
No, it's new, but it's good.
Totally new. It's new, but it's good, huh?
Yeah.
Okay. Example 5. Example 5 says summation from k equal 4 to 24 of k cubic. Ooh, again, the same problem. Our summation do not start in 1, start in 4. Start in 4. So you split from 1 to 24 because it's exactly the formula. But wait a second, this is 4. Sorry, this is 4. My formula compute in 1 second that part. But I need to subtracting something, the same formula, but k starting 1 and ending in 3. Because I need to compute the summation from 4 to 24. But I have the formula to compute from 1 to any number. So from 1 to 24 and delete mentally no, arithmetically, from 1 to 3. Okay? And the formula, let me copy the formula for the cubic. Is similar to that formula, is n plus 1 divided by 2, but this is square. Okay, entonces es easy. Look, es 24 times 25 divided by 2 square. This is the first one. And the second is 3 times 4 divided by 2 square. Okay, entonces that part is 24 times 25 divided by 2. It's 12. It's 12 multiplied by 25, 300. 300 here. 300. 300 square. Don't forget that. Minus, this is 6 square, 36. And the answer is 89,964. It's a big number. It's a big, big number. Okay, super. Let's move into another example. Example 6. Look, summation from k equal 20 to 50 of the 80. What the hell is that? Okay, in this case, the expression inside the summation do not depend of k, it's a constant. And you put like a common factor, yes, you put like a common factor. You put 80 if you want. Summation from k equal 20 to 50 of 1, ¿no? Entonces, in between 50 and 20, they are 31 elements. Because look, let me show you. It's 20, 21, 22, bam, 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 to 50, no? It's actually 50 minus 20 is 30, right? But if you include both endpoints, you're adding one more. Okay, so actually, this summation is not 30, okay, the subtraction 50 minus 20 is 50 minus 20 is 30, plus 1, because include both endpoints, is 31. The answer is 31 times 80 is 2,480. Do you understand this idea? Let me try to explain. And using one straightforward example. Suppose. To make clear, suppose that we are doing k equal 3 to 5. It's easy to understand, to 80. And you expand k equal 3, 80. Plus k equal 4, 80. And k equal 5. 80, no? 80. Entonces 80 plus 80 plus 80 is 240, no? 240 is the answer. Wow. And what is the formula? I don't know. The formula is a constant, is 80, multiplied by something, multiplied by 3. And where come from this 3? You're subtracting 5 minus 3, 5 minus 3, plus 1. Because include 3 and 5. Both endpoints. Entonces es obvio que es 5 minus 3 es 2. 2 plus 1 is 3. And 80 times 3 is 240. Do you understand? The same idea here. You're subtracting what? The upper limit. Subtracting the lower limit. And consider one more. Plus 1. Okay? Okay, guys. Example 7. Okay, example 7 is summation from K5 to 40 of minus 3K. Okay. Okay, first of all, number one, I factor out the minus 3. So my problem is I forgot minus 3. I multiply the final answer by minus 3. And it's a K5 to 40 of K. Right? And this is equivalent minus 3. And you split that in summation from K equal 1 to 40 minus another summation from K, again, same expression, but K is 1, always I supposed to apply the formula, we need K equal 1 to 4. So 1 less than 5. And that's it. And remember the formula is summation from K equal 1 to M of the K is N plus 1 divided by 2. Actually, it's minus 3. That guy is 40 times 41 divided by 2. Minus, this is 4 multiplied by 5 over 2. Do you understand very well where I come from 41 and 5? Yes, N plus 1. In the first summation, N is 40, and the second summation, N is 4. Okay, this is now minus 3 times. This is the 820. And this is 10, no? It's 20 divided by 2, 10. So now you're subtracting is negative 3 multiplication by 18 is negative 2,430. Yes. Okay, no bad. Okay, I have 2 more examples. You have not too much. That's a property. Okay. Example 8 and 9. I have 2. Not too long, it's easy. Example 8. Is summation from K equals 6 to 20 of 4K squared. Okay, nice. I like that. You factor out that 4. And you have summation from K6 to 20 to K squared. Yeah, I know the formula for the K squared. Okay, is, but the only problem is starting 1. Is M plus 1 to M plus 1 divided by 6. That's a formula for this. But I need to manipulate a little bit because this formula is possible applied when the K is starting 1, not in 6. So you split the summation in 2 summation. One summation starting 1 to 20 K squared, and another summation starting 1, always starting 1 to 5. It's the previous of 6 K squared. Okay, no problem. I understand. So 4 and the formula. Look at the formula. The formula is weird. The formula is, this is the most popular formula in calculus. Is M, que es 20, multiplication by 21, multiplication by 41. Where come from 41? 20 times 2 is 40 plus 1 is 41. Divided by 6. Minus. The second guy is 5. Multiplied by 6, get 1 more. And 11, no, 11. Where come from 11? 11 is 5 times 2 is 10 plus 1 is 11. divided by 6. The rest is calculated. You put here, this is 2,870 minus 55. That makes sense, 55, because cancel out this 6. 5 times 55. Now subtraction and multiplication by 4, the answer is 11,260. Okay? Super cool or super sophisticated? Okay, let's do one more. Now we have time to start a little bit next section. Okay, number 9 is, look, it's easy in my opinion. A summation from k equal 1. Oh, nice. I appreciate so much that k is 1. I don't need to split. This is k squared minus 7k plus 2. This is the explicit formula inside the summation. Okay, no problem. I know very well the property you separate in 3. The first one is summation from k equal 1 to 24, k squared. I know the formula for this. Minus 7, que is a constant, summation from k equal 1 to 24 of k. I know the formula for this. Plus 2 times 24, because it's summation, actually. Summation from k equal 1 to 24 of 2. But I know that when there's a constant, you multiply this number and this number, F48. F48, actually. And the rest is a formula. The formula for the square and the formula for the non-square. The formula for the square is, I want to repeat again, is n plus 1 to n plus 1 divided by 6. In our particular example, 24, 25, and 49. Because it's 2 times 24, que 48, plus 1 is 49, divided by 6. Minus 7, don't forget this factor. And this is 24 times 25 divided by 2. Plus, don't forget 48. No? The answer this part is 4,900. The answer that part after the multiplication is 2,100 plus 48. And the final answer is 2,848. Boom. Entonces es super easy. Manipulate the summation because it's a linear operator. Linear operator means, when you're talking about linear operator, is when you have summation, and you have several, A sub m, B sub m, from n equal 1 to something, well, k, much better k to m. You separate, and we have a constant coefficient 5, 6. We put the 5 outside, summation, k equal 1 to m, a sub k, plus 6 summation from k equal 1 to m, b sub k. This is a linear operator. You have complicated expression, pero linear operation. You separate. Linear operator. And the majority operator. And the majority of operator in calculus are linear operator. We study different operator, new one that you don't know. You study, I promise. Majority are linear operator, including the summation. Are linear operator. Operator. Okay. So the rest of the time we have today, I spent study one easy part of the sequence. Okay, is called arithmetic sequence. Arithmetic sequence. arithmetic sequence. What is that? It's super easy to understand. Look. One sequence like that. Suppose 4, 6, 8, 10, y I suppose que repeat it, same pattern. Es arithmetic sequence because the common differences que normally is called D is constant. What is the common difference? When you're subtracting 6 minus 4 is 2, 8 minus 6 is 2, 10 minus 8 is 2. This is D. D is constant. So we have common difference, constant. Now when this situation happens, the formulas to find A sub m in general is equal to A sub 1 plus n minus 1 D. Let me identification. A sub n is any element inside the sequence. A sub 1 is the first one, and D is the common difference. What is the formula, specific formula for this introduction example? Okay, A sub m is equal. A1 is 4. Because this is the first element, okay? I suppose that M, this is A1, this is A2, this is A3, this is A4. Plus A minus 1, and the common difference is 2, no? The common difference is 2. So you manipulate a little bit algebra here. Why not? 4 plus 2n minus 2. So 2n plus 2. Because 4 minus 2 is 2. Entonces, the A sub n specific formula for this arithmetic sequence is 2n plus 2. Suppose que I want to evaluate a 4. It's 2 times 4 plus 2. 2 times 4 is 8 plus 2 is 10. Do you see it matching perfectly? And so on. I need to find A to the whatever, 500. Plugging in 500 here. 500 is 100. 500 is times 2 is 1000 plus 2 1002. Okay, this is the formula. This is the most important formula in the arithmetic sequence. Okay, let's see one interesting example. Okay. Okay, suppose this example. Okay, look. Suppose this sequence is given 2, 6, 10, 14, 18. Yeah, I need to find, and this continues forever, guys, a sequence. When you talk about sequence, it's infinity, no? Okay. Entonces I need to find, si es possible, no? A sub m is the explicit formula of the A sub m position element.
X equals 17.
And why no? A evaluated in 41, the position 41. That's easy because if you have the general formula, you select the position you want. This is A sub m, and this is m. 1, 2, 3, 4, 5. So I need to discover the formula. What is the formula? Well, the formula is plain. It's A sub m is equal to A sub 1 plus n minus 1d. Who is d? What is the common difference? This is important. You subtracting is 4. So the first thing that you should do is verifications if it is arithmetic sequence or no. So you're subtracting and the answer is 4, 4, 4, 4, 4. So you're subtracting one element and minus the previous element, and the answer is constant is 4. So you make sure que it's arithmetic sequence. And the common difference is equal to 4. Then the formula is A sub m is equal to, it's the first element, plus a minus 1 times 4. Okay, algebra 2 plus 4n minus 4 is 4n minus 2. It's the formula. A sub n formula is 4n minus 2. And this formula allows me to compute any position inside the sequence. Suppose I want to compute the position 41. Okay, let's do it. A and 41 is equal 4 times 41 minus 2. 162. Boom. Final answer. Clear?
Clear.
Okay, let me complicate a little bit. Suppose we have, I need to find the formula for the one arithmetic sequences. Okay, I know that A sub 8 in the position A is 75. In the position 20 is 39. Entonces my question say find the first one, que es A1, find D, que es the common difference, find the formula, A sub n. Let me see if I did well. Yeah. Okay. This is given, but not given the complete sequence. Two elements inside the sequence. One in the position 8 and another in the position 20. You find the first, the common differences, and the general formula to find that. Okay, so I apply one more time the most important formula, que es A sub n is equal A sub 1 plus n minus 1 d. Pero I know que at n equal 8, this guy, que es A sub 8, is 75. Plus A sub 1, I have no idea. But sorry. This is equal. It's obvious equal, this guy. 75, que es equal A sub 1, plus A minus 1, que es 70. Oh, I have one equation that contains two unknown, A1 and D. Okay, and the position 20, the answer is 39. This arithmetic sequence is weird because it's decreasing. It's decreasing. So in the position A is 75, however, in the position 20 is 39. See, this situation happens is because the common difference is negative. And instead of addition and subtraction, it's possible. But the formula is the same formula is A sub 1 plus 19. We come from 19, 20 minus 1 d. And this is equation 2. Then you have two equations, so it's possible to find the solution. No? This is, in this case, you subtracting equation 1 minus equation 2. We have equation 1 minus equation 2 is, well, A1 is cancelled out, and this is minus 12 d, because it's 7, no? Minus 19 is 12 d. It's equal 75 minus 39 is 36, right? Okay. Now d divided by negative 12 both sides. It's obvious that d is negative 3. It's suspecting the common difference is negative. That is a reason that the sequence is decreasing. We start in the position 8, 75, and decreasing. Decreasing how? Minus 3, minus 3, minus 3. In the position 20, we have 39. And see, increasing, it becomes negative, I suppose, in one moment. So we are ready. No, not yet. But I need to find A1 to find A1, well, you take either equation. How far walk? You take either equation. For example, you take either equation and substitution here, and the first equation maybe is 75 is equal A1 plus 7 times negative 3. 75 is equal A1 minus 21. Therefore, A1 is 75 plus 21 is 96. Wow. My sequence at n equal 1 start in 96. Okay. This is what a formula. One of the formula is, so one more time you apply that idea, look, that formula. A sub m is equal to 96 plus n minus 1 multiplication by negative 3 getting. Well, algebra, 96 minus 3m plus 3. 96 plus 3 is 99 minus 3m. Oh, this is the formula. A sub n is 99 minus 3m. You can check it if you want. Yeah, you can check it. For example, for n equal 1, the formula says that A1 is equal to 99 minus 3. Okay, 96. Good. Look at that. For n equal 8, A sub A is 99 minus 3 times 8, okay, 24, no? So 99 minus 24 is 75. Good. 75. Now for n equal 20, A sub 20 is 99 minus 3 times 20. Okay, 3 times 20 is 60, no? It's 60 to 99 minus 60 is 39. Wow, fantastic. 39. Okay, do you see the word? So the three answers they want is number 1, find the A1. Okay, the answer was here 96. D negative 3. And A sub n is that formula. This is the three answer. Okay. Okay. Okay, just stop for a moment like that. We continue the arithmetic sequence next time, more complicated. Because basically today we studied only the formula to give me the position, but I need to discover more information, so summation. Okay, so stop so far, stop, and we continue next time. Okay, guys, have a nice afternoon.
Thank you,
Thank you,
Professor.
Professor. You as well.
Okay.